Hello, everyone. A very warm welcome and thank you for joining today. I am Raminder Dhiman, a senior product manager at Cognistx, and today we are going to talk about data quality and how our product data quality engine helps to improve it. We will begin with a brief company overview along with some case studies. Then we will switch to understanding data quality, its dimensions, how does poor data quality impact, and what is the problem at core. After that, we will talk about data quality engine we have developed at Cognistx, its capabilities and processes. And also we're gonna deep dive into one of our features, which is optimized routing. And at the end, we'll share some of the product's metrics and KPIs. And then we'll open the ground for some question answering. So Cognistx was founded in 2015, and our roots are at Carnegie Mellon University School of Computer Science. Our team has an entrepreneurial background with different startups that have been built by our co-founders. We are world experts in cutting-edge AI technologies, which includes computer vision, natural language processing, and predictive analysis. Our current team size is around 30, and we have served many world-class industry leader clients. We have two patents that are issued, and there are multiple patents that are already applied. Sanjay and Dr. Eric are our co-founders. So Sanjay has over 28 years of experience in AI, e-commerce, and software development. And Dr. Eric Nyberg is one of the world-renowned AI expert. He's professor and director of Master of Computational Data Science program at Carnegie Mellon University. He is also a member of original IBM Watson development team. Okay, so these are some of the notable case studies where we have worked with and then deployed data quality engine and other solutions that we have built at Cognistx. So AmeriGas is one of propane industry leaders where we have deployed our data quality engine, and Armada is another company where we deployed DQE, Suburban Propane, Evoqua, PPG Paints, SAE. So there are different solutions that we deployed on all of these clients of us. Let's begin with understanding data quality. Data quality is measurement of condition of the data based on four main dimensions that are accuracy, completeness, consistency, and reliability. Accuracy is the degree to which the data correctly represents the entity or attribute. An example would be telco detecting that John, J-O-N, good data, and John, J-O-H-N, good data, are very likely the same person if their records have the same address. Reliability means there are no duplicates. The data is recent and meets the industry or organizational standards. In order for the decision to be reliable, the key data must be discoverable, usable, and current. Let's move on to have a look at the high overheads of data quality. Why is data quality important? Turning raw data into improved business performance is a multi-layered problem, but it doesn't have to be complicated. To make things simpler, let's start at the end and work backwards. Ultimately, the goal is to make better decisions during the execution of a business process. This can be as simple as not making a customer repeat their address after a handoff in a call center, or as complex as replanning an entire network of flights in response to a storm. The end goal in all cases is to make a decision that improves the future health of the business. And that requires decisions that are both accurate and timely. A report from IBM found that poor data quality costs 3.1 trillion to the US economy annually due to lower productivity, system outages, and higher maintenance costs, to name only a handful of bad outcomes that result from a poor data quality. In order to be accurate, the decision has to be based on good and trusted data. Everyone who works in an office has experience with bad data, and most have seen it lead to bad decisions. According to a survey by research firm Gartner, Organizations believe poor data quality to be responsible for an average of $15 million per year in losses. There are many reasons data utilization may be low. A major one is low quality. A recent study on the lack of trust around data from research firm Vanson Bourne found that 91% of IT decision makers believe they need to improve the data quality in their organizations, while 77% said they lack trust in their organization's business data. Increasing data accessibility would well benefit Fortune 500 businesses in theory. In practice, data access alone won't provide the lift. Let's understand the reasons behind this high impact. The reason bad data costs so much is that decision makers, managers, knowledge workers, data scientists, and others must accommodate it in their everyday work. And doing so is both time consuming and expensive. The data they need has plenty of errors. And in the face of a critical deadline, many individuals simply make corrections themselves to complete the task at hand. Quite quickly, this business of checking the data and making corrections becomes just another fact of life. Let's assume there are two departments, A and B, to understand how this data quality problem trickles down the line. Department A completes its work and delivers to Department B. Now, Department B, in addition to doing its own work, must add steps to accommodate errors created by Department A. After correcting most of the errors, some still leak through to the customers. Thus, Department B must also deal with the consequences of those errors that leak through, which may include issues as angry customers and bosses, packages sent to the wrong address, and requests for lower invoices. Salespeople waste time dealing with bad prospect data, service delivery. People waste time correcting flawed customer orders received from sales. Data scientists spend enormous amount of time cleaning data. IT expends huge effort lining up systems that just don't talk. 75% is the fraction of total cost associated with data anomaly identification and cleaning in process. It's pretty clear we definitely need better data quality. One of our main products we have been focusing on in the last 3 years is our data quality engine at Cognistx. Data quality engine helps companies clean their data with a combination of business rules and artificial intelligence and machine learning models. One of the capabilities of data quality engine is artificial intelligence powered data anomaly detection. Data quality engine has pre-built business intelligence models that helps to identify inaccuracy, incompleteness, inconsistency, and unreliability of the data. It saves enormous amounts of time of various departments by directly pointing the users, data scientists, subject matter experts to the specific problem without users needing to go through hassle of checking multiple tables and databases. Data autocorrection is another capability that we have developed in data quality engine. This feature helps in normalizing, cleaning, and completing the data while improving the consistency and reliability of the data. By understanding the structure and form of business domain and needs, data quality engine models recommends and cleans the erroneous data. By experimenting with various types of data sets and continuously improving data quality, we have come up with multiple applications of artificial intelligence that equips our customers with cutting-edge solutions. For example, by looking at the addresses, shipment resources, order details, and historical delivery data, data quality engine can create the most optimized delivery routes so the delivery team delivers more orders during their day, enhancing the business output from the same cost. And we're going to talk about this particular feature in a little bit more detail. By continuously monitoring the customer data, historical orders, and various other data points, data quality engine can predict if an order created may be rejected before it's loaded and shipped, saving crucial time and dollars. For example, a downtown McDonald's weekly orders 9,000 chicken nuggets, and suddenly that order changes to 90,000 nuggets. Our models will quickly identify the possible data anomaly and flag it to the relevant user before it is loaded and shipped, saving time and money by reducing the unnecessary operational overhead. A single source of truth is not just joining different data sources spread across cloud, legacy systems, third party, or even home built apps. Even if consolidating is desired, it is not an easy feat. Fortunately, data quality engine doesn't only create one true view of different data sources, but it also does it in a way that you can rely on it. The continuous monitoring of data quality helps teams identify areas where processes can be improved within the organization, enhancing this entire supply chain. Let's have a look at one of our features that has gained a lot of traction in the industry, optimal routing. Before the solution, let's talk a little bit about the problem. So designing optimal routes from a district to a set of stops, customers, each with business-specific constraints, such as vehicle limitations, cost controls, time windows, resource limitations concerning the loading process, is challenging. Since each vehicle has a maximum load capacity, you must always consider the weight and volume of what's being transported. The challenge is to save costs by transporting more goods in one trip without exceeding the vehicle's capacity. And there might be additional complications. For example, there are multiple distribution centers, limited subset of vehicles, different dimensions of cargo, different capacity of each vehicle, and multiple compartment vehicles as well. So at Cognistx, for in data quality engine, we deployed and developed this particular feature of optimal routing, where we have applied multiple levels of artificial intelligence models to achieve and deliver the most optimal route for our customers. And the very first layer that we work around with is basically rezoning or rebalancing of the clusters where each and every truck can go. So the objective over here is allocate trucks or resources based on location of customers for specific days. So the very first level in clustering is where we define as K. It can be configured by the customer, and it is also defined as the number of trucks. And this can be changed on the basis of different zones, on different districts, and wherever the deliveries are required. And then once that is defined, the balancing of clusters is the next thing that we basically do. If count of customers per cluster exceeds a certain threshold, we balance the customers from a larger cluster that are closer in location to the closest available smaller cluster. So basically what you can see in the diagram is it's not necessary that all the customers that are present on the lines of these boundaries, they can be in cluster A or B. But our artificial intelligence models, they automatically, by understanding the historical delivery patterns and everything, they create and balance all the clusters. Now, the second layer that we do is latitude and longitude as inputs. So once those are used, we generate clusters using the number of trucks and resources and headcounts, which is also configurable by the customer depending on the number of trucks that are present in different zones and districts. After initial clusters are generated, they are also balanced. If count of given center exceeds balanced count by a certain threshold, we also shave off some accounts which are not really required in that particular delivery route, which happens to reduce the goods delivered in that particular route. So that's one of the key metrics that we also focuses on. And then we also add to the mix of acceptable delivery days and frequency, where we use day level clustering requires frequency and acceptable days, because each and every customer does not accept delivery on the same days. And each and every customer does not have the same frequency as accepted frequency. So all of those changes are added to the mix, which leads to an optimal route. So We basically talked about inputs as trucks, headcount per district, how many districts are there, how many trucks are there, how many distribution centers are there, different customers. And then we also take into account of count data, customer to district mapping, location data, frequency of delivery, threshold for estimated volume of delivery, and then we also add threshold number of stops per day. And once all of these inputs are fed to the models, the result is basically a cluster of customers allocated for each truck on specific days per district. So as a result, we will get to know that this truck needs to go to this zone, and these are the customers that needs to be catered for that day. And this will be the whole schedule for that particular day for all the trucking resources for a distribution center. That's the final output. Okay, let's have a look at the process that we have created at Cognistx to enhance data quality. The very first step is, of course, getting the customer data, and it can be through any ERP, CRM, or it can be structured or unstructured data. Once we get the data, it is prepared for input to the system via cloud storage dump or API integration. Then the data is ingested and prepared for the rule engine application through pre-processing, cleaning, and normalization. It is also fed into the models of data quality engine. Then our models applies business rules and AI/ML to identify and track anomalies and suggest corrections on the basis of historical data, how the data was corrected, and what should be the ideal value of this wrong data input. We also start recommending what should be the right data value of these fields. And once we are recommending all the clean data, of course, there needs to be a validation layer before it goes into the production system of our customers. And once they are validated, clean data is then updated in the database. And of course, there is a dashboard that presents anomalies and clean data for user interaction and feedback to further improve system accuracy. We at Cognistx finished this process of starting to identify data issues and cleaning data via data quality engine in weeks, if not months, because we want our customers to realize the benefit of artificial intelligence as soon as possible and not have to wait months for it. Let's have a look at some of the benefits and metrics of KPIs. So AI-enabled data will result in significant operational improvements. Some of the operational efficiencies we have delivered for commodities, distribution, supply chain, propane distribution, oil and gas are in shape and form of anomaly identification, data cleansing, reduction in inefficient deliveries, reduction in unnecessary customer service stops where nothing was delivered, prevent running out of commodities, improved customer service, and better strategic options. So some of the metrics data quality engine have achieved in the last few years are 10 million data anomalies have been identified till date. And it is consolidating all the customers that we have until now. Around 2 million records have been cleaned without human involvement. So automatically the inconsistencies were identified and data quality engine suggested clean data, and it was cleaned in the production, and 2 million records were basically cleaned automatically. And this has resulted in saving around 1 million person hours for all of our customers involved. Data quality engine created around 30 million worth of value to our customers till date. And around 400,000 customer accounts have been cleaned permanently, and 300,000 bad orders that were generated that would have caused unnecessary operation heads have been identified and flagged even before they were packaged and shipped. The benefits of improving data quality go far beyond reduced costs. It is hard to imagine any sort of future in data when so much is so bad. Thus, improving data quality is a gift that keeps giving. It enables you to take out costs permanently and to more easily pursue other data strategies. With that, I want to thank you all for joining us today. And please feel free to post your questions in the chat section. Okay. So we have one question about how much time it takes for SMEs. So thanks for that question, Patty. Some of the it depends, varies from customer to customer, but at an average, we require around 2 to 3 hours of the SMEs of customers in the first week, and from second week it reduces down to one hour or something per week. So not a lot of time. But thanks for that question. Okay, so are there any other data quality products and how does yours differ from them? Okay, so yeah, absolutely. There are a lot of data quality products and it's around $100 billion industry in US right now. Uh, how do we differ is we are very much targeted towards some specific set of problem statements in specific industries. So for example, propane distribution is one of the industries where we have industry leaders as our customers, where we have deployed and have been successful, and then also in supply chain. And then in paints manufacturing, we have also started gaining some traction because of some new solutions that we have created. So the way that we are identifying is that we have this speciality in these 3, 4 industries where the other generic products will have a tough time, creating those solutions specifically for them. Okay, so another question is how much does it cost? So the cost of data quality deployment actually varies from customer to customer. It depends on several factors. For example, how much data is there, how bad the data is, and what all other features do we want. But basic process is there is a small one-time fee to deploy data quality engine, which takes around a couple of weeks to deploy. And then to keep on using DQE, there's a very small SaaS-based fees every month paid. Okay, so what kind of forecasting can data quality help with? Okay, so there are different types of forecasting that we have currently. So, for example, I talked about propane distribution. In that industry, we help with forecasting if a particular order created will be good or bad. So that has been creating a lot of value because it reduces inefficient fills and it reduces 0 gallon deliveries in that industry. And it also helps with preventing any out of gases for the customer. And then another forecasting that we do, for example, in paint industry is even before a small batch is created and there's a lot of cost involved in order to create a new paint, what we can forecast is on the basis of historical experimentations, if there's a new paint color required, for the very first step, we can provide with the perfect raw materials, temperature, colors, and everything else as inputs that will result in the required paint as an outcome. So that saves a lot of cost for paint manufacturers. So that's another thing that we have developed as forecasting. Okay, I think we quickly talked about different data quality products that are present in the market. So we will skip that question. How long might it take to get DQE up and running for the customers? Okay, so as we discussed, usually it takes around 2 weeks to 3 weeks to understand the business domain and then deploy all the solutions that we have already built. And once it is built, it's not really a lot of effort that is required from the customer side. It keeps on running. And then, if there are new enhancements or new problem statement that we find out in the customer daily processes or operations, that will take additional time, and then we can probably work on that. But to answer your question, around 2 to 3 weeks. Okay, I think those were all the questions. So thank you all for joining us today. And these are some of our details for Cognistx.com, where you guys can, this is our website where you can go and look at our other products and solutions. And you can reach out to me at Raminder@Cognistx.com for more questions related to data quality engine and optimal routing. And you can also reach out to Sanjay at Cognistx.com, who's our CEO and co-founder.